हेलो बच्चों, कैसे हैं आप लोग। उम्मीद है आप लोग अच्छे होंगे और मन लगाकर पढ़ाई कर रहे होंगे। आज आप लोगों के लिए एक बहुत ही इंटरेस्टिंग टॉपिक लेकर आया हूं और उस पर हम लोग बहुत अच्छे से चर्चा करेंगे। और ये टॉपिक इंटरेस्टिंग इसलिए भी है क्योंकि ये बहुत यूज़फुल है। ये टॉपिक जो है मैथमेटिक्स से रिलेटेड है, बट जो है ये कई सब्जेक्ट में यूज़फुल है। जैसे फिज़िक्स में इस यूज़फुल है, आपका केमिस्ट्री में है, और अलग अलग साइंस में यूज़फुल है। जैसे आपका जियोलॉजी में यूज़फुल है, आपका जियोफिज़िक्स में यूज़फुल है। और जहाँ भी हाइट डिस्टेंस मेजरमेंट होता है वहाँ जो है एंगल के रिस्पेक्ट में जो भी मेजरमेंट करने होते हैं वो यूज़फुल है। आपका ज्योग्राफी में यूज़फुल है। सो इसलिए ये टॉपिक बहुत ही इंटरेस्टिंग होने वाला है। So today in this video lecture we are going to discuss about the mathematical topic, that is introduction to trigonometry. So there is a statement that tells there is perhaps nothing which so occupies the middle position of mathematics as trigonometry. So this statement is by J.F. Herbert, and it tells how much the trigonometry is useful in our day-to-day and scientific arena. So let's start the video lecture. And the introduction about this chapter, which is belonging to chapter number 8, is that you already familiar with the triangles and right angle triangles. So बच्चों, please look into the picture. This is the picture of very famous Qutub Minar that is situated in Delhi. And suppose you are happen to be there and you want to measure the height of the Qutub Minar. So can you do that without any instrument? So yes, you can do that by application of the trigonometry. So we'll learn about those tactics. How can you measure the height of this Qutub Minar? Suppose similarly there is another case where a girl is sitting on the balcony of her house located on the bank of a river. She is looking down at flower pot placed on the stair of a temple situated nearby on the other bank of the river. So you can imagine the right angle triangle is formed, and by using the trigonometry here you can measure the height of that girl from the river surface. So these are the examples which can be solved by the application of trigonometry. Similarly, here a story is, suppose a hot air balloon is flying in the air. A girl happens to spot the balloon in the sky and runs to her mother to tell her about it. Her mother rushed out of the house to look at the balloon. Now, when the girl had spotted the balloon, initially it was at point A. When both mother and daughter arrived to see the balloon, it had already traveled to another point B. So, can you find the altitude of B from the ground by using the two positions of the balloon A and B, and by application of the trigonometry? So, yes, we can do. So in all the situation given above, the distances or heights can be found by using the mathematical techniques that is known as the trigonometry. The word trigonometry is derived from the Greek words that states for tree for meaning three, gon for meaning sides, and metron for meaning measure. In fact, trigonometry is the study of relationship between the sides and angles of a triangle. So, basic definition of triangle is that this is a relationship between the sides and the angles of a triangle. The earliest known work on the trigonometry is recorded in the Egypt and Babylon literature. The useful of most of the technological advanced method used in engineering and physical sciences are based on the trigonometrical concepts. So in this chapter, we'll discuss about the trigonometric ratios of the angle and also the trigonometric identities such as sine theta, cos theta, tan theta, and inverse of those cosec theta, cot theta, sec theta, and the identities like sin square theta plus cos square theta, cos square theta minus sin square theta, tan 2 theta, and so on. So, so let's learn one by one. So, what is the trigonometric ratio? You have seen some right angle triangle to be formed in a different situation. So let us imagine ABC is a right angle triangle and this angle is A. So here this side adjacent to angle A is known as side adjacent to angle A, and it is also called base, and the side opposite to angle A, and it is also called the normal or perpendicular, and this is the hypotenuse. So this is the triangle. Now what happens if you change the angle? So accordingly the normal and base of the right angle triangle will change. So in this case now this will become the base of the right angle triangle for the trigonometric ratio, and this will be the normal or perpendicular. So now let us define the trigonometric ratios. Sine of angle A, cosine of angle A, tan of angle A, sec of angle A, cosec of angle A, and cot of angle A. So we can define this by considering the sides. Let us consider we are talking about this triangle ABC. In this case we are taking the angle A. So for sine of angle A will be given by the length of this side opposite to angle A, that is normal, to the hypotenuse, right? Similarly we can define the cosine of angle A is equal to side adjacent to A divided by the hypotenuse. That means cos of A is equal to base divided by hypotenuse. Similarly we can define the tan of angle A, that will be given by the ratio of side opposite to angle A and divided by the base, that means BC by AC. So here you can see that given is for the angle A, sin A is equal to BC by AC, cosine A is equal to AB by AC, and tan A is equal to BC by AB. Generally we used to write sine of A, angle A, as sine A. So this and this are same, right? Further, the cosec is the inverse of sine A. Sec of A is equal to 1 by cosine A, and cot of A is equal to 1 by tan A. Now let us consider the case symbol sin A is used as I told you that sine of the angle A. Sin A is not the product of sine and A. So if we write sine of angle A, that means this is the whole quantity. This is not the product of sine and angle A, right? Similarly, cos of A is not the product of cos and A. So please don't be confused. that these are the products. These are a single quantity. Now what if we take this case? In this case angle is same and we are taking the sides of the right angle triangle different. So in all these cases the value of sine of A, cosine of A, tan of A and their corresponding inverse quantity will be always same. It is not going to change. Here the proof is given. You can study this. The value of the trigonometric ratio of an angle don't vary with the length of the sides of the triangle if the angle remains the same. Now we will discuss about the problem. Let us take the example 1. So it is given that tan of A is equal to 4 by 3. So find the other trigonometric ratios of the angle A. So tan A is given and it is asked to find the sine of A, cosine of A, cot of A, cosec of A, sec of A, all those things. So firstly by this we will find the sides of the triangle and hypotenuse. So by the definition of tan A, it is given as the ratio of the normal to the base. So in that case, suppose tan A is equal to 4 by 3 is equal to k. So in that case, the normal will be 4k and base will be 3k. So this value will be this square plus this square root. So 16 plus 9, 25 is that will be equal to 5k, right? So accordingly you can find the sine A, cosine A, cot A, cosec A and so on. Now the example 2 is if the angle B and Q are acute angles such that sin B and sin Q are equal, then prove that the angles are also equal. So that means if sin of B is equal to sin of Q, then prove that their angles B and Q are also same. So for that we will define sin B and sin Q. Since sin B and sin Q are equal, we will equate this value. Therefore AC by PR is equal to AB by Q, AB by PQ. Let us say this is equal to K. So we will find the values of BC by using the Pythagoras theorem and QR. So that will give BC by QR is equal to AB square root AB square minus AC square divided by square root PQ square minus PR square, and we will get this BC by QR is equal to K. So from the equations we get AC by PR is equal to AB by PQ is equal to BC by QR. This gives the, by using the theorem of similarity, that angle B is equal to angle Q. Similarly, let us consider the case example number 3. So you are given the triangle ACB where you are given the value of hypotenuse and value of base side, that is 21. So by using Pythagoras theorem you can find this value, that is 29 square minus 21 square, that will give 20 units. So now find the value of cos square theta plus sin square theta. So actually this is an identity and it will be equal to 1, but in this case we can prove this by using the side of these sides. So let us prove. So firstly we will find the sin theta and cosine theta and then square and add this. You will get that this value comes out is equal to 1. Similarly, we can find that cos square theta minus sin square theta, that is equal to 41 divided by 841. Now example 4, in a right angle triangle ABC, B is right angled. If tan A is equal to 1, then verify that sin A cos 2 sin A cos A is equal to 1. So tan A is equal to 1, that means this value and this value are equal to 1, right? Tan A, this is tan A, so this will be the normal and this will be the base. So 1 by 1, tan A is equal to 1 by 1, that is 1. So you can find the sin A and cosine A, then this value will be equal to square root 2. So you can find that sin A is equal to 1 by square root 2 and cos A is equal to 1 by square root 2. Therefore 2 times sin A cos A is equal to 1. Similarly, you can also do this example number 5. Now move further. So please do this exercise. These are very simple exercise. You can do this, and if you face any problem, let me know. So now trigonometric ratio of some specific angles. So we will find the sine, cosine, tan, cot, sec, cosec for specific value of angle, that is 0, 30, 45, 60, 90. So these are the values which are very useful in the physics, geology and other domain of science. So let us see what are those values. So let us suppose this is right angle triangle ABC, and this angle is 45, then the other angle will be also 45. So that means this side will be equal to each other, and suppose this is A, then this will be also A, and this will be equal to A square root 2. Accordingly, you can find the value of sine 45, cos 45, tan 45, and that will come out as 1 by square root 2, cos 45 is equal to 1 by square root 2, and tan 45 is equal to 1. So these are the fixed values, and you should remember this